So just on a whim, basically I swapped these out. I don't know if it was these ones, might not have been. It blew one of these things. So on a whim I just swapped them out for these higher voltage ones, 500 volt ones, which I don't need for this. And yeah, it basically hasn't made a difference. These are still getting hot and these ones are still staying cold. So I think that whilst the problem is these ones. For some reason I think these are switching harder, right, and these ones aren't switching as hard, or something like that. It's possible the circuit isn't switching them on properly or fully. I don't know, but I can see now, because you can see now that they're both switching both ways. All three channels are switching both ways. Just about make the colour difference between them. All the LEDs are lighting, which means, because it's running faster than the eye can see, basically. We've got the motor connected, but because all three are at the same potential, then we're really not making any. We've not got any potential across the motor itself. Not until I actually switch it to BLDC like that. Now you can see it's changed, yeah, and that's back to PWM, right? But we're cooking these transistors. So I don't know, and I need to check these guys to make sure. All of these I need to check them, basically. I wasn't blowing any MOSFETs. I thought I was blowing these MOSFETs when I connected them, but I wasn't. What was happening is that because the BC547 was locked on, it was just basically switching it on as soon as I put the gate resistor in. So I don't know. Yeah. And it's possible that it might work better if I take the gate resistor out. I'm just a bit concerned that it only seems to be pulling it high. Excuse me. And not low. It could be just an offset, because the idea is it's got to be a voltage offset between the coils. But I don't know. Anyway, I think it's tea time now. So we're okay. We're understanding the circuit better. We've certainly got the software to give us a better indication of what's going on. And if I pull out two of these, right, and then switch it to BLDC mode, then you can actually see, if I turn it there so you can see how it's gating, you can actually see that it's gating fine and switching fine. Look at that, you see. The one that's different, basically, is, if I can maybe scale it up, there we go. So the one that's different, because you can see like two lines are over the top of each other. Maybe it'd be easier if I actually separated them slightly, just a tad. Let me just position it slightly differently. So if I say that one, if I just move it down like something small, a small voltage, and then the orange one will move slightly up. There we go. It's right now they're separated, so it makes it easier to see, doesn't it? Right. And when there's two lines together, right, the third line is the one that's actually providing current, right? But sometimes you'll see where there's like a line in the middle, right? And the line in the middle is the one which is switched off. You see, so you've got one that's pulling high, another one's pulling low, and another one's pulling off. But then at other times you've got two pulling in one direction and one pulling in the other. Do you know what I mean? And then like there, where they're all switched off, because that's a space. These are the marks and these are the spaces, and it's just which way it's pulling with the mark. And you can see how it's kind of rotating, which it actually is, of course. That's the whole point. You're making the field rotate so the magnet follows you. So it is like that. But I don't know. Yeah. Let's try and get it a bit. Yeah. On another scope, I actually made it so that it actually didn't. It just treated all of them as one. Yeah, but I'm not getting that now on this one. No. Yeah. So there we go. I don't know. I'm not sure. When it's not connected, it's working fine. When the motor's not connected, but when I connect the motor, everything seems to go high. So it's almost like the P channels are being switched quite hard, right? But the N channels aren't being switched properly, because that's why they're getting hot, because they're partially switched one way or the other. Yeah, I think they're not, because they have to pull it down, so they're not being switched fully on. I think that's what's going on, basically, that these N channels are not being switched fully on. And it might be something to do with the circuit, actually, now I come to think about it. Yeah, I don't know, because we're conducting down from here, but the voltage is actually here, right? Because it's called an emitter follower, because that follows that. You see, now this one is connected at the moment because we've got a Zener in there. This is connected to the 12 volt, and that means that when that's switched on, so when this one goes low, right, then that means because you've got a diode, I think it's a 5 volt, and this is actually 9. So when that's low, then this switches this point here, TP1, right, to 5 volts. Okay, so this one goes between 10 and 5 volts. Well, it doesn't go between 10 and 5 volts because this rail is 9, so it goes between 9 and 5 volts basically, right? And that means that this base here, the potential difference across there, is being switched between 0 and, you know, whatever, 0.7, 0.8 probably, right? And that turns this one on and off, and then that means that this point here is going between 0 and 9 volts. That's the idea anyway, right? And I haven't put the gate resistors in there. Well, actually they're in here. Which means this point here is going between 0 and 9 volts, which means this point here is going between 0 and 9 volts. Yeah. Which means this thing should be turned, this should be saturated both ways. And it isn't. Possibly. I don't know. Hello?